All right, we're going to go over the AKS 12A and 13A tests. So question 1 here says, which angles have measures of 43 degrees? And in this picture, we see that these two lines are parallel to each other, and they're being cut by this transversal. So we want to find all of the angles that would be congruent to this angle using the relationships when two lines are cut by a transversal. So one of the first ones that I see, we know that 2 is a vertical angle with this original angle right here. Remember, vertical angles are always congruent, so 2 is 43 degrees. Now, if I were to draw on this picture, remember we can draw the letter F. And when we draw an F across these two lines cut by a transversal, that shows us corresponding angles. So using this, I could see that 6 is corresponding with that 43 degrees. So those two are also congruent. And for this last one, we could do a few things. I see that 4 is a vertical angle with 6, so it must be 43 degrees. You could have also used another set of corresponding angles, and that would be right here. Draw another backwards F, and you would see that those two are congruent. And so we would say 2, 4, and 6. All right, let's look at the next one. So question 2 says, are lines C and D parallel? Explain your reasoning. So notice these two angles that we have. We have this angle up here and this one down here. If I had to classify their relationship, notice how both are on the outsides of lines C and D. So one's above and one's below, so they're on the outsides. And they are on alternate sides of the transversal. So this one is in the top left, this one is on the bottom right. And so those are alternate side exterior angles. And we know that alternate exterior angles should be congruent if these two lines are parallel. But are those two angles congruent? No, 105 and 100 are not the same. So because they are not the same, we would say no, these lines are not congruent because alternate exterior angles are not congruent. In question 3, it says determine the measure of angle IEU. So IEU is right here, but we don't have any information about that angle yet. So we're going to have to use what we have in order to find this angle. So far what we have, I've got this angle right here and this one right here. If I want to relate those two together, notice I have two parallel lines cut by a transversal. If I trace through, I can draw the letter Z, which means these two are alternate interior angles. And we know that alternate interior angles, when the lines are parallel, are congruent. So I know that these two angles must be congruent to each other. Since they're congruent, I will set each expression equal. So 3x plus 20 is this angle here. And I'm going to set it equal to the other angle, 5x minus 6. Since they're congruent, we can set their measures equal. Now I'm going to use this to solve for x. So I'll start by subtracting 3x from both sides because I want to move all the x's together. And so I always move the smaller one. 5x minus 3x is 2x. Bring down the minus 6, and I'll bring down that 20. In the next step, I'm going to add 6 to both sides. So we get 26 equals 2x. Next, to get rid of that 2, I would divide both sides by 2, and we get 13 equals x. Now, I want to use this information to find our missing angle. Notice IEU is a vertical angle with this angle over here, which means those two are congruent. So I could take 13 and plug it into this expression, and it'll tell me the missing angle that we need. So I'm going to plug that in. We get 5 times 13 minus 6. 5 times 13 is 65. Minus 6 is 59. So the correct answer here is 59 degrees. All right, question 4, a similar question. It says determine the measure of K, which is this angle right here. In order to find this, I first need to use the information I'm given to solve for x. So notice these two angles were given. They are above and below the parallel line, so they're on the exterior. And notice that they're both on the left side of the transversal. So these are same side exterior angles. Now, same side exterior angles are supplementary. So instead of setting them equal, now I'm going to sum them. So 10x minus 9 plus 15x plus 14 equals 180 since they're supplementary. So now I'm going to simplify this. I want to start by simplifying the left side of the equation by combining like terms. So 10x plus 15x is 25x. Then we've got a positive 14 and a negative 9. So 14 minus 9 is a positive 5 equals 180. Next thing I want to do to solve for x is subtract 5 over to get the x's by themselves. So we get 25x equals 175. Then I want to divide both sides by 25 to get x by itself. We get x equals 7. Now I want to use that to find the missing angle. So if I'm going to relate this angle to one of those two that I know, notice that the angle that we want down here is an alternate exterior angle with this one up here, right? They're on the exterior of the parallel lines and one's on the left, one's on the right. And we know that alternate exterior angles are congruent. So therefore, 10x minus 9 will give me the angle that we want. So I'm going to plug in 7. We get 10 times 7 minus 9. 10 times 7 is 70. Minus 9 is 70 minus 9 is 61. So 61 degrees. All right, number 5. Describe a rigid transformation that will map angle 1 to angle 2. So here is angle 1 right here. I'm going to trace it. And then I'm going to pick it up and move it. How could I move angle 1 so that it lands right on angle 2? Notice all I had to do here was slide angle 1 down. They both open to the top right? Both of them open up this direction. So I don't need to twist it so that it opens differently. I just need to slide it down so that it's onto angle 2. Yeah, and I'm really sliding. Notice it has that vertex there of the angle. I want to slide the vertex. So now the vertex is on point C. So looking at these, I know I want a translation and I want to map 1 onto 2. So notice there's 2 that say translate. The first one says translate angle 1. The second one says to translate angle 2. But we know that we want to translate 1 onto 2. So it's got to be the first one. And it goes from the directed segment from B down to point C. All right, let's check out this next one. Describe a rigid transformation to map 4 to 3. So I'm going to again trace 4 to help us see it. Notice that angle 4 opens up this direction, but angle 3 opens in that direction if I were to trace it. So that means I can't simply translate this because if I just translate it, it's not going to land on angle 3. I also need it to move in another direction. Instead, for this one, what we want to happen is we want this one to not just move, but also to rotate around, and then it will land on angle 3. So we know we want a rotation here in order for it to rotate from opening up to opening down. So not a translation won't do. That is not even a rigid transformation. And we said not a reflection, we want a rotation. So if I rotate 180 degrees around the midpoint of EB, so EB is here, just so you see it, the midpoint would be right here. So that's kind of like what we did. We took this angle and we rotated it around the midpoint. Notice how I'm just keeping that one line. Oop, it's hard to do with your fingers always. Not perfect, but notice how that line kind of stays right there, touching this red midpoint. So that was our correct answer. All right, for question 7, we're filling in the proof for the vertical angle theorem. And it says angle 1 and 2 form a blank. Well, let's look at where angle 1 and 2 is. Here's angle 1. Here's angle 2. Notice together they make up a full line, so they form what's called a linear pair. Because they form a linear pair, they are what we call supplementary. This means that the measure of angle 1 plus the measure of angle 2 equals blank. Well, because they're supplementary, that means that they sum to 180 degrees. Angle 2 and angle 3 also form a blank. Well, let's find 2 and 3. So here's angle 2, there's angle 3. They form another linear pair. This means that the measure of angle 1 plus the measure of angle 2 again equals 180 degrees because they're supplementary. Using substitution, we can see that the measure of angle 1 plus the measure of angle 2 must be equal to the measure of angle 2 plus the measure of angle 3. And the reason this is true is because they both equal 180. So they must be equal to each other. Applying the subtraction property, we know that the measure of angle 1 equals the measure of angle 2. Or now we can say that angle 1 is congruent to angle 3. Sorry, and I meant to say angle 3 up here as well. Measure of angle 1 equals measure of angle 3. But remember, when we're not talking about measures anymore, we have to then switch over to using congruent. In question 8, complete the proof of the theorem. If two lines are crossed by a transversal, then alternate exterior angles are congruent. The first thing that we always start with is our given, right? So we have in the statements that M is parallel to N, and the reason is our first blank, and that first reason should be given. The next part B that we want to fill in has its reason, and the reason is that parallel lines implies corresponding angles are congruent. So we know that we're dealing with corresponding angles. We need to list some. So which angles are corresponding? And you could come in here, remember corresponding, we draw the letter F. So I could draw an F right here, backwards. And I could say that angle 2 is congruent to angle 4. Now, there are other pairs of corresponding angles here, and you could have used a different pair. But then your statement C has to be different than what mine's going to be. So be very careful about that. Now that I know that 2 and 4 are congruent to each other, and I want to show that 4 and 1 are congruent to each other, is there a way that I could relate angle 2 and angle 1? And yes, there is. We know that angle 2 is congruent to angle 1, that's C, and then D down here is because they are vertical angles. So vertical angles are congruent. So if you wanted to use a different approach, you could have in the second line use some different vertical angles. And you could say that angle 1 and angle 3 are your corresponding angles. So if I were to say angle 1 is congruent to angle 3 for B, then in C, I need to relate 3 to 4. So I would say that angle 3 is congruent to angle 4. So remember, you just have to be consistent and make sure you're showing everything you need in order to get to the end.